guys figure out? Whatever you looked up, definitions in the book, Googled it, whatever you did. Can somebody explain to me what these words are saying to us if somebody starts talking about variance or standard deviation? Awesome. Okay, good. So these values show us how much the other values in the data set deviate from the mean. Okay? So yesterday, most of the measures that we talked about measured center of the data, like mean, median, mode, okay? Seeing where the quartiles were. That helped us measure how the center of the data looks. Things like the range help us measure how spread out the data is. And standard deviation and variance are other measures that help us measure how spread out the data is. So when people talk about data a lot, they talk about the center of the data and the spread of the data, because we want to know kind of where the data is centered around and how spread out is it to help us interpret what that data might mean in a specific situation. Is there a difference between variance and standard deviation? Okay, so one shows a squared value and one doesn't. So there's a difference in the way you calculate it, right? They would be different numbers, but they both are measurements just measuring how spread out things are from the mean. Does that make sense to everybody? Okay. So when you hear the word standard deviation or variance, people are just trying to explain to you, here's your mean. Some of the data is this far away. Some of it's 2 standard deviations away or 3 standard deviations away. It's just going to tell you how spread out it is. Okay? The larger the number for standard deviation or variance, the more spread out it is, because that means here's your mean, and one standard deviation extends a lot further than it did before, which means you have data points in that window and then even further beyond that possibly. Okay? So the bigger it is, it shows you that it's more spread out from the mean. And then depending on what your data is about, you could take that and interpret it how you would need to. Right. So definitions are basically the same type of idea. They're both measuring the same thing. People just might use one instead of the other. We're going to focus a little bit more on standard deviation in our class, okay? But it's important that you guys understand that variance is just taking that measure and squaring it. So here's how you actually do the calculation, okay? And this is, again, from your textbook, so it's not anything different from what you have. So you find the mean of the values of the data set. How can you measure how far things are from the mean if you don't know what the mean is? So the first thing you got to do is find the average. Okay? Then you find the difference between every piece of data in your data set and the average. So this would really suck if you had like 50 pieces of data like you guys are going to have, right? Because you would have to figure out your mean and then you'd have to subtract it from all the 50 pieces of data, because that kind of measures how far each individual piece is from the mean, right? Then we take that and we square it. Okay. Remember how we talked about before, like the r and the r squared thing? Squaring gives us a little more leeway, like takes away some of our error, because if it was small, it'll make it slightly bigger so that we're not tricked into thinking it's that close. It will also take anything that was negative, and it would make it positive, so you won't be dealing with any negative values there. Then you find the average of all of these things that you just found. Okay? So you add up all those things and divide it by how many pieces there are. That is considered the variance. The square root of that would find you the standard deviation. Okay? So there's kind of an intense process to figure it out. Right? We're going to do this process with smaller sets of data, and we're going to let the calculator do it for us with larger sets of data. It is important, even if you get to use the calculator, that we know how the calculation works. Okay? To understand questions like, what if I change the value of each piece of the data and increase everything by 10, how is that going to affect the standard deviation? If I know how the standard deviation calculation is done, I can kind of reason through that a little bit and see what would actually happen if all the numbers were increased by 10. How would that affect the mean? How would that affect the differences? All of this kind of stuff, okay? So you could still be asked questions that may require you to have knowledge of how it works, even though the calculator can do the actual calculation for you. Does that make sense to everybody? Okay, so you want to have an idea of what you have to do to find this so you understand how it works. But we will be using the calculator to help us, because once you get beyond a few data pieces, this is a really annoying thing to have to go through over and over again, okay, because it's a big calculation. So if you didn't write down a definition for variance and standard deviation, and you're not going to remember what they are, make sure that you write down something that they're helping you measure how spread out the data is or how different the data points are from the mean of the data. Okay, something that helps you understand it measures spread, specifically how different they are from the mean. All right, so we're going to do one calculation by hand so you can actually understand how it works. And then more after that. All right, so we're going to find the mean, the variance, and the standard deviation of this data set. Luckily, the data set is only 5 data points. Okay. So the first thing we want to do is we want to go and find the mean. Remember that the average, and that the symbol that we sometimes see used for that is that X bar. Okay. So you can use a calculator still. Okay. I'm not saying you have to add and divide by hand. I'm just saying you're not going to just be able to put the numbers in a list and say, do this. But we will in a minute. But right now, we want to go through the calculation one time by hand. Okay. So go ahead and first figure out the average. So our mean is 5.22. Okay. And then the symbol that you saw on the last page, back there for a minute, this symbol right here is like a lowercase sigma. So you guys have used the uppercase sigma before, these Greek letters, I know. Okay. That was the uppercase sigma that meant summation. This is the lowercase sigma, okay? And so it stands for standard deviation, but when it's squared, it's using variance instead. So they're measuring the same thing, one is just the square of the other. Okay? So if we want to go ahead and we want to calculate the standard deviation and the variance, the same thing happens. The formula said, back again, capital sigma, big sigma, so do the summation of these things. Okay? So what that means, the formula says we're going to do the summation of these and divide by how many things that there are. Okay? So what that means for us in this case, how many pieces of data are there? 5. So I'll be dividing by 5. N is 5 because there's 5 pieces of data. How many things then am I going to be adding together if there are 5 pieces of data? 5. Because for each piece of data, I have to find its difference from the mean and square it. Each piece of data gets its own little difference that's being squared, that's being added together to find this average. So I would take my first piece of data, 6.5. I would subtract my mean and square. Okay? So one piece of information. Okay? So that's measuring how different that first piece of data is from the mean that you found. Okay? Then we want to do the same thing for the second piece of data, third piece of data, etc. So you're going to have all these different differences. See why it would be annoying if you had a really big data set? Okay. All right, so remember what variance and standard deviation are measuring. They're measuring the difference between your data points and the mean. So notice that what you've done for each data point is measure its difference from the mean and then squared it. So then you get all these single numbers like, oh, this one's this far, this one's this far, this one's this far. And you want to average them to see on average how far are they away from it. We're going to add all these together and divide by 5. So because it's measuring how different things are from the mean, you literally take the difference from the mean for each data point individually, square it so that we don't have to have any negatives or anything like that messing up our calculation, and then average all of those separate things so you get one number that says, okay, based on all the data points on average, here's how far away they are. Okay? Now, what we're doing right now, if we just do this calculation, this is actually our small sigma squared because this is the variance. Okay? How are we going to get the standard deviation from the variance? We're just going to square root it, okay? So why don't we go ahead and finish this calculation, figure out what the variance is first, and then we'll just take the square root of the variance to get the standard deviation, okay? So go ahead on your calculator, figure out what this is. changed my mind about rounding to 2 decimal places. Instead 4 instead because it would just round to 1, but I wanted you guys to see the difference between the number. But, so we should get 0.9976, right? If you didn't get that, I would check your calculation. A couple of things. Make sure you're using a minus sign and not a negative sign in this problem when you're subtracting. Secondly, do not calculate each of these individually and round them, and then add them together and divide by 5. You should put this entire calculation in, and you shouldn't be rounding till the very end. Otherwise, because you've rounded 5 different decimal things that were squared and then averaged them, it's very possible that your answer by the end of that could look maybe significantly different than ours, depending on the rounding that occurred. Does that make sense to everybody? So don't round those numbers till the end. Seeing it? Okay, that's fine. Yeah. Oops. This is probably not working. So my video is probably not going to sound. We'll see. All right. So what's the difference between our variance and standard deviation? Right, what is squared and what is not. So they're measuring the same exact thing. They even do the calculation the same way. This is going to be how people choose to talk about it. Do they want to use variance when they talk about it, or do they want to use standard deviation? We're going to delve more deeply into the standard deviation realm. Okay? So the standard deviation is the same exact formula from variance. So we don't have to redo our calculation, except for the fact that it's been square rooted. Okay? So to calculate our standard deviation, we would basically just need to take our variance and take the square root of that value. So we should, since our number is so close to 1, I'm just checking what the number will be. Yeah. When you take the square root of it, you should get something also very close to 1, right? So, okay. Something like this. Okay. Yes. All you do is square root the variance. Okay? So the standard deviation has one extra step in the calculation, which is to square root it. So if I was just calculating standard deviation, I wouldn't have rounded here. So what I would have done is typed the entire variance thing into the calculator, pressed enter, and it would have given me some crazy decimal, right? And then in the calculator, I would have pushed, take the square root of that, like the square root of the answer, and then it would have given me this, so that I didn't round anything till the very end. Okay? And the reason for that is you have multiple different decimal calculations in your thing. If you're rounding each one of them and then using them, you might end up kind of far off depending on how much rounding took place. Okay? All right, is this okay with everybody? So these are kind of weird calculations, but again, remember they're trying to measure how far things are from the mean, so they literally take each piece of data, measure how far it is from the mean, and then they average those calculations. Okay? And so it's just a number. It's just giving you a number. But what this does is it kind of gives you an idea of how spread out things are, especially if you wanted to compare two different types of things. You could see which one was more spread out than the other, and then you could make an informed decision on which one maybe was better for you, whatever the data was about, based on what mean, median, and mode, what those center things were, and then how spread out the data was. Okay?
So that's like the average of how far away each of them are?
Yeah. Yeah. And so that's how it measures spread of the data. So the calculator can do this for us. All right, so we're going to go ahead and use the calculator and put this information in and see what information the calculator can give us without us having to do this. Because even though this is only 15 pieces of data, do you guys want to calculate standard deviation or variance by hand for these 15 pieces of data? No, it was hard enough for like 5 pieces of data, right? 15 would be super annoying, okay? So calculator can do it for us. Again, then why do we have to know how it's calculated? Well, one, how are you going to understand it's a measure of spread if you don't understand that it's measuring how far each thing is from the mean? 2, how are you going to be able to predict how different values would change if you didn't understand how it was calculated? So the calculation is not something we're going to tediously go through over and over again. I don't want you to be little human calculators and be like, okay, I'm going to take this 20-piece data set and calculate by hand the standard deviation. That's not my goal. Put it in the calculator and let the calculator do it for you. But I want you to understand the standard deviation, which is why we went through the calculation one time to really understand what it does. Okay? So we're going to put all of this data into our calculator. Yep, so same thing like we did yesterday. So this will kind of review the calculator part from yesterday because we did that part quickly. So first of all, notice the data. Sorry, let me go back here for a second. So the data is a data table. So it looks like it's bivariate data, like, oh, here's one piece of data and here's the second piece of data. But all we want to know, so it displays the number of sales a salesperson made each month during the past 15 months. We just kind of want to know how much sales do they make each month. So we're not going to make two tables, okay? The column that says month 1, month 2, month 3, does that really matter to me which month she made 6 sales in? No. I just want to know that my list has 4 in it this many times and 1 in it this many times. So I'm basically just using the sales list as what I want to find the mean, the median, the mode, the standard deviation, anything like that up, okay? So we're only putting in one list of data. So again, go to Stat, go to Edit, pick whichever list you want and put in your data. Now remember, if you're annoyed by numbers in a list and you want to clear it out, you can go onto the name of the list and press Clear, not Delete, okay? That will delete the list, okay? Press Clear and press Enter, and then there will be no data in that list, and then you can start new by entering your data, okay? So then I'm going to go ahead and I'm going to enter the data you see on your note guide. So on your note guide, go ahead and enter the data numbers. Remember, just for sales, okay? There should be 15 data pieces when we're done, because there were 15 months that we recorded. What I want to do with this data, I want to do a bunch of calculations on list 1. I want to find mean. If I wanted to make a box and whisker plot, I would want the minimum, the Q1, the median, the Q3, the maximum, okay? I will now want to be able to know how spread out it is, so I want to know things like the variance or the standard deviation. The calculator can do all of that for me with the same calculation we did yesterday. So what calculation was it that we were trying to do yesterday? How does the calculator title the stat calculation that we're trying to do? One var stat, right? One variable statistics, because these are basic things that people calculate when they deal with statistics that are in one variable, okay? So we got to that by going to stat, and then calculate, and then we chose choice 1, one variable statistics. And then we told it which list our information was in. So if your list is in a list other than list 1, make sure you put something else. Otherwise, list 1 is kind of the default. So in the older model here, if you didn't type it, it would assume list 1. When you guys get to the menu, it already says list 1 in it, right? There is no frequency that you need to input, and so then just push calculate or press enter, and then we should have our information, okay? So for our data, what is the first piece of information it gives us? The mean, okay? So that X bar represents the mean. So the mean was 4.4. So X just represents data points. So it says if you added up all the data points, you'd get 66. If you added up the square of all the data points, you'd get 340. We're not using that information, okay? But then notice the next two, okay? The S and then the small sigma. If we want the standard deviation, we're going to use the small sigma notation like we used before. So we're going to use sigma of X. So we'll record that as the standard deviation. So we'll say it's 1.82. Remember that n equals 15 is just telling us there were 15 pieces of data. And then if we wanted to move forward to make like a box and whisker plot of this data or wanted to know something about the quartiles, we could use the information that's listed beyond that in the menu. Okay? So going back to the question, they just asked us for the mean and standard deviation, so we have recorded those things. And now actually on the calculator, the S, see how close these two numbers are? The S is also a standard deviation measurement. One of them is considered like the population standard deviation. One is like the sample standard deviation. So your calculator is giving you two measures of standard deviation, and as you get deeper into statistics, you'll see what the difference are. And I'm actually going to check. I don't want you guys to get the answer wrong according to the book by what they said, so I just want to make sure that we picked, yeah. So we're being consistent with what your book is picking out as the standard deviation. So 1.82 would work for us, okay? Are we good with this? All right? Okay, so mean and standard deviation, your calculator will do it all for you if you just put the data in the list. So if those are things that you want to calculate when you get your 50 pieces of data for your project, put your 50 pieces of data in the list and let the calculator do it for you. I don't need to see you calculate standard deviation by hand or something if you want that piece of information. This is fine, okay? All right, the last thing we're going to talk about, and then we'll let you guys work on some homework, okay? All right, this is how we actually use it. So it might have seemed a little weird that we're talking about this number that just measures how far away pieces are. Like, why do we even care, or why is that important? When people use standard deviation, they generally use it to answer questions like this, okay? Using the sales data from example 2, so we already put that data in and got the analysis from the calculator, okay? Within how many standard deviations of the mean do all the data values fall? Okay. So basically what's happening here is you're saying that your mean was what? What did our mean turn out to be for that example? 4.4. So we're saying .4 was our mean, okay? It's kind of the average of our data. When the standard deviation comes out to be 1.82, that means if you moved one standard deviation this way, you're moving 1.82 units, okay? And so what number would be 1.82 higher than 4.4? 12, 6.22, okay? So anything that's between 4.4 and 6.22 is within one standard deviation of the mean. It's not too far away from the mean. Does that make sense to everybody? So this is why the standard deviation number was given to us, to kind of measure, like, well, how much of our data is close, how much is a little further, a little further. And so we kind of made up this new term of measurement to measure that. Oh, well, you fall within one standard deviation of the mean. Like, oh, you're pretty close to the mean according to the spread of the data. You're 5 standard deviations away from the mean. What would that tell you? Like, you're kind of odd, right? Okay? According to this data, right? You fall really far away from the mean according to this calculation if you're like 5 standard deviations away from the mean. All right? Maybe that's a good thing, okay? Maybe it's a bad thing. Depends on which side you're on and what the data's about, probably, right? Okay? So that's just kind of telling us, it's like a new way to measure, like how many standard deviations are you away from the mean, right? Are you kind of really close to average or like really not average? And is that a good thing or is that a bad thing, right? And that can help us interpret the data. But you can't only move, you can move both directions. So when they say one standard deviation away, they don't just mean in this direction. I could also move one standard deviation away in the other direction. Okay. So what number is 1.82 less than 4.4? Okay. I don't know. I have to do subtraction. Is it set? Should be more than 0.58, right? 2.58. Okay. I was like, Okay. So 2.58. So basically, if I was, like, let's say I was a boss of all these salespeople making their monthly sales, right? And the data I had was for my company and for multiple people. When I looked at this, I would expect on average that my salespeople would sell about make 4.4 sales a month. If they were between 2.58 and 6.22, I would consider that pretty normal because anybody in that range was still within just one standard deviation of the mean, meaning they didn't vary that much from what the average was. Does that make sense to everybody? Okay. And again, you might say, well, I think that varies a lot. That's what you think, but according to the data, these numbers aren't that much variance from the mean because they're within one standard deviation. We use the data to determine how far away is too far away, right? Okay. So when we looked at our data, look back at your data in number 2 to answer the question here. It said within how many standard deviations of the mean do all the data values fall? So far, from 2.58 to 6.22 would be just one standard deviation from the mean. Are all the numbers of monthly sales between 2.58 and 6.22? No. So there were months where they fell beyond one standard deviation away from the mean. Is that okay with everybody? So we need to check further, right? We need to go further out and see if we then encompass all of the sales. So remember, this was my mean. To go 2 standard deviations away from the mean, so above the mean, 6.22 was one standard deviation away. The next standard deviation away would be to add another 1.82. Remember, the number I'm adding is not me deciding. The data decided with the standard deviation calculation that this should be how I measure it, right? So what is 6.22 plus 1.82? So 8.04. And what is 2.58 minus 1.82? 0.76? Okay, so this means if we considered all sales between 0.76 and 8.04, we would be considering all sales numbers that are within 2 standard deviations of the mean instead of 1. Does that make sense to everybody? Okay. And again, that standard deviation was determined by the data. So then we have to look at our chart to answer their question. They specifically wanted to know within how many standard deviations of the mean do all the data points fall? Is all the data on monthly sales between the numbers 0.76 and 8.04? So there's nothing smaller than 0.76. There's nothing that goes beyond 8.04. So we would say all of the monthly sales fall within 2 standard deviations of the mean. Okay? So that makes sense to everybody, how standard deviation is used to measure different like chunks, kind of chunks things together. Okay? Yes. Yeah. Right. Yeah, because you can go either side. So this is only considered from 0.76 to 8.04 is only 2 standard deviations away from the mean. Because 2 standard deviations away means you could be 2 below or 2 above. Okay. All right. So within how many standard deviations? 2 standard deviations. And we're going to do more about this. So you guys, when you took your notes on like Monday, you guys look at 11.8, which is the next section we're going to talk about on Monday of next week. That was all about sampling and survey. Given that you guys already took the notes and we did that little PowerPoint introduction to your project, you guys have a lot of general information about that. Your book has some more specific terms and stuff that we're going to delve into using there. Then the last section we're going to cover on like Wednesday of next week is going to be section 11.10. And it talks about normally distributed data. Like, you know how you guys always say, oh, you're going to curve our test? And I always tell you, you don't really want me to curve your test. You want me to scale your test, right? Like, you all just want a better score, right, than what you got, okay? To curve your test would be to take all the scores and say, okay, here's the average, okay? I'm going to have the most amount of C's happening right there around that average score, and that anyone that's this far above the average can have a B, but the people this far below the average will have a D, and the people this far above the average will have an A, and this far below will have an F. So if people actually curved tests, let's say you all got between 90 and 100, the people that got 90% would have Fs. Does that make sense? Because it would be an evenly distributed, here's the average, same number of this as this, same number of this as this, just based on what your scores were. Okay? So this whole normal distribution thing is the curve that looks like this, where you'd have like the maximum amount of C's going on, and then a little less B's and a little less D's, a little less A's and a little less F's, that kind of thing. This type of curve, not every distribution is normal. Okay? But the ones that are, you have your mean, and the way you figure how significant someone's score is how many standard deviations they are away from the mean. So this information that we talked about today is sometimes a little hard to understand separately. Like, it just seems like, okay, this is random calculation, and we just like count how many of those it is away. But when we get to that section that we're going to study next Wednesday, it's going to help us determine, like, do people fit in the population correctly, or are they way outside of the normal height? Okay, like I take my daughter to the doctor, and the doctor tells me, oh, she's between the 25th and 50th percentile in height and weight or something like this. I don't know how she's so small. I'm not very small, but apparently that's what she is, right? So he tells me that information. What is that information based on? That information is based on statistics about how big 3-year-olds are, right, height-wise and weight-wise. They took all this data. They can calculate a mean and a standard deviation, and it generally does look normal, like most of the population falls in here. Then there's people that are taller than that, and then taller than that, and then taller than that. Those people are a lot more standard deviations away from the mean. And there's people that are shorter than that, and shorter than that. They're a lot more standard deviations away from the mean. So this might make a little more sense than just doing a calculation and answering kind of a simpler question like this when we're doing it in the context of what we're going to get to next week, just to kind of preview that for you guys, okay? So we've done 2 sections this week. We'll do 2 sections next week, and that's it as far as textbook sections for this unit, okay? Does that make sense to everybody? So tonight's homework 3. We'll check homeworks 2 and 3 and answer any questions you have tomorrow. We'll just work on that tomorrow. That's it. In addition to the fact that you want to upload your surveys tomorrow and how you're collecting your data. So the actual questions that you're planning on using and how you're presenting them to people and where you're going to collect your data and how you're going to collect your data so that we can have my extra set of eyes look at it just to make sure I don't see any outstanding bias that maybe we could adjust something before you start taking surveys next week. Kara?